Hi guys, Ms. Burns here. I figured we would take a look at some of the problems in section 8.2 because as I said the other day in class, I think chapter 8 is a really important chapter, but I also think some of these questions are kind of difficult. And I know I didn't get a chance to show you, or we didn't spend much time talking about how to calculate some of these hypothesis tests in StatCrunch, so I want to make sure you see that. So I don't have, not in the classroom, so I can't write on the screen like I normally do, and long story, I have to use the computer instead of the iPad like I do for the videos. So I'm just going to talk through some of these problems as best I can, and hopefully this will help you at least see the patterns and see what we're talking about. So I'm just going to click through and pick a few questions. I'm looking at section 8.2. This is question number 3. It says, when asked whether marriage is becoming obsolete, 709 out of 2,000 randomly selected adults answering a particular survey said yes. We are testing the hypothesis that the population proportion that believes marriage is becoming obsolete is more than 35%. I highly recommend you get some paper out and you write these down, or if you're in front of your computer and you're using your own questions, use the numbers in your questions, but write some of these things down as you go through the question. So for example, write down what you think the null and the alternative hypothesis is. So 34% is what we're comparing everything to. So your alternative or your null hypothesis would be that P equals 34%. Your alternative would be that P is greater than 34% because it says more than. They're telling us to use a 5% significance level. One of the following figures is correct. Indicate which graph matches the alternative hypothesis. P is greater than 34%. There it is. So what you want to think about here is that this is a right-tailed one-sided test. Remember, when it's greater than, that means you shade to the right. So the only picture that fits this would have to be picture B. All right, and then it says report and interpret the correct p-value. So they're giving you the p-value in the picture. The p-value, remember, and I know there's a lot of p's going on, so the notation is confusing, but the p-value they're talking about here is this shaded area, this black shaded area right here. So it says because the p-value is, so now what you want to do is you want to compare this 8% to your significance level of 5%. That's how you decide whether you're going to reject the null hypothesis or fail to reject the null hypothesis. So in this case, the p-value is about 8.5%. Your significance level was 5%. So that means your p is large. It's larger than your significance level. So it says because the p-value is greater than the significance level, if it's a large p-value, that means we fail to reject the null hypothesis. We only reject if the p-value is smaller than your significance level. So that's the important thing right there. That means there is not sufficient evidence to conclude that the population proportion is greater than the 34%. In other words, there is not evidence in support of the alternative hypothesis. The alternative hypothesis up here was that P is greater than 34%. Based on this p-value, we do not have enough evidence to support that. So we fail to reject the null hypothesis, and we say there is not sufficient evidence to conclude the alternative is true, that the population proportion is greater than 34%. All right, let me just kind of click through here, see what else looks interesting. Let's take a look at this one. It says, according to a recent survey, 19% of an adult population suffer from an anxiety disorder. Suppose a test of 300 random college students showed that 55 suffered from an anxiety disorder. So 55 out of 300 would be your p-hat. That's your sample proportion. It says, according to a recent survey, 19% of the adult population. I know it's confusing because it says according to a survey, but they're making the claim that the population of all adults is 19%. So that actually is your p-value, your p for your population proportion. That's your parameter. Part A says about how many 300, about how many would you expect to have this if the 19% is correct? So what I'm going to do is I'm going to find 19% of 300. Let me open up the calculator on my computer so you can actually see what I'm doing. Here we go. So we want 19% of the 300. So 9.19 times 300, 57. So I would expect about 57 adults in my sample to have an anxiety disorder based on that 19% number. Suppose you are testing the hypothesis that the population proportion of college students suffering from anxiety disorder is not 19%. Okay, pay attention to the way this is phrased. Is not 19%. So your alternative hypothesis would be that P does not equal 19%. So if it does not equal, that means it could be higher or lower. that means you have a two-tailed hypothesis test. So when you see does not equal, that means a two-tailed hypothesis test is what you're working with. The only picture that fits is C. So the tails in both ends are going to be shaded. And what that means also is that you've got this test statistic. So your test statistic, remember, which comes from your sample, your test statistic is your z-score. That means your z-score has a positive value and a negative value. So it could either be below the negative z-score or above the positive z-score. So interpret the p-value. So the p-value that goes with this, here's your p-value right here. That's the area of both of these tails added together, the area shaded in. And your p-value is 7685, 76%. How does that compare to a 5% significance level? Obviously, that's much larger. That's a very large p-value. So let's take a look at the choices and see which one fits. Okay, so what does this mean? So if my p-value is large, my p-value is larger than my significance level, that means that we do not reject the null hypothesis, okay? We don't have enough evidence to support the alternative hypothesis, whatever that was. So in this case, if we don't reject the null hypothesis, that means that we are going with the null hypothesis of the 19% number. So let's take a look at these questions. It says, if 19% of the population suffer from an anxiety disorder, then there is a blank percent chance that we will observe a z-score less than the negative 0.2943 or greater than the positive 0.2943. So the p-value is these shaded areas, and that's the probability of getting your particular sample. Your particular sample is represented by the z-score. And because it's a two-sided test, that means we've got our z-score, our p-value is going to include values that are less than the negative or greater than the positive of whatever that z-score or that test statistic is. So yeah, let me read that again. If the 19% of the population, so if the real population is 19%, then there is a, whatever p-value is, 76, let's see, they said 2 decimals, so 76.85% chance that we will observe this particular test or this particular z-score. Okay, one thing, and I started to talk about what this meant, and I said that we fail to reject the null hypothesis. That is true. They didn't ask us that in this question, so I didn't get to that part of the question. But you do need to know what the p-value tells you. The p-value, remember, that's the probability, that's the likelihood of getting your particular sample or something more extreme if the null hypothesis is true. So in this problem, if the 19% number stands for the population proportion. All right, let's see what else we have here. Let's see. I'm trying to find one that we have to use StatCrunch for so I can show you how to actually do this stuff in StatCrunch. Okay, let's look at this question. I think this is one we can use StatCrunch on. It says, according to a reputable magazine, 31% of people in a certain country have sleepwalked at least once in their lives. Suppose a random sample of 200 people showed that 42 reported sleepwalking. The null and the alternative hypotheses for a test that would test whether the proportion of people who have sleepwalk is 0.31 are, so here's our null hypothesis. P equals 0.31 for the null, and the alternative is P does not equal 0.31. And the does not equal comes from the question where it says, let me see, determine whether the proportion of people who sleepwalk is, so like whether or not it's 3.31. Could be higher, could be lower, it doesn't say. The conditions for the test are satisfied. Use the technology output to determine the test statistics. Okay, so they actually gave us a picture of StatCrunch. All right, so here it is. So the test statistic is right here. That's your z-score. That's the negative 3.06 number. So let me go ahead and write that. Negative 3.06, because I said 2 decimals. All right, and then it says determine the p-value. The p-value is also given to you in the StatCrunch output. So the p-value in this case is 0.0022. So 0.0022. By the way, on the test, you won't have access to StatCrunch. And so, oh, wait a minute. Oh, it says 3 decimal places, 0.02. Let's try that. On the test, you won't have access to StatCrunch. So what we'll do is we'll give you a screenshot just like this. So the goal is to make sure you can interpret whatever this tells you. All right, so then it says, what is the conclusion? All right, so the conclusion would be what? My p-value is 0.0022. The question you need to ask yourself for the conclusion is, how does this number compare to the significance level? Is it more than the significance level or less than the significance level? So in this case, it is less than the significance level. This is less than 1%. If I move the decimal over, this gives me 0.22%. So this is smaller than the 5% significance level. So what does that mean? When we have a small p-value, that means that we reject the null hypothesis. So in this case, we will reject the null hypothesis. So that means we have evidence to support the alternative. If we reject the null, that means we think the alternative is probably true. So we would say there is sufficient evidence to conclude that the proportion of people who have sleepwalked is not the 31%, because that's what my alternative hypothesis said. P is not 31%. All right. Okay, let's see. Like I said, let's see if I can find one that uses StatCrunch. I think the next one is very similar. Let's take a look. Let's try one of these. This looks like, I think, one we could use StatCrunch for. So it says, this is number 12, a 2018 poll of 3,621 randomly selected users of social media found that 2,465 get most of their news about world events on their site. Research done in 2013 found that only 48% of all users reported getting their news on world events about this site, or about world events on this site. So I think the 2013 population, or the 2013 statistic, or I should say parameter, is our population proportion. The 48% is what we want to compare it to. So our 2018 poll is going to be our sample. So it says, does this sample give evidence that the proportion of site users who get their world news has changed? So come up with the hypotheses that go with this. So your null hypothesis always is P equals some number, and in this case, they want us to compare it to the 48%. The alternative is based on where it says, does this give you evidence that news has changed, or that the number has changed? So then we're going to say not equal to the 48%. Let's check that. Okay, compute the test statistic. Now, we can do this by hand. In fact, I think the other day in class in section 8.1, we talked about a formula that you can use to compute this by hand. However, I'm going to use StatCrunch to do it. So let's talk about what to do in StatCrunch. So I'm going to question. Let's go to StatCrunch. Let's open up the window. And then here's how we access all of the stuff about hypothesis testing. We're going to go to Stat, and then we're going to go to Proportion Stats, One Sample. It's exactly the same thing we did for confidence intervals, and I'm going to go to With Summary. I have to put in the number of successes. So for my sample, let me go back real quick and get those numbers. So my sample, it was 2465 out of 3621. So let's put that in. So 2465 out of, I forgot the number. Let's see, 2465 out of 3621. So 3621. So if they ever give you a proportion as a percentage, you've got to get the number. You have to convert it to a number of successes out of your total for StatCrunch. So when we did confidence intervals, remember we clicked on confidence interval. Now I'm going to leave it on hypothesis test. And then you need to tell the StatCrunch what your hypotheses are. So my null hypothesis for this question was that P was equal to 0.48. My alternative, you can pick the symbol you need, but I wanted not equal to. Remember, mine was not equal to 0.48. So I'm going to click compute, and here we go. So my z-score, notice what it tells you. Here's the count. That's my number of successes out of my total. There's p-hat if I needed it. There's the standard error if I needed it. My test statistic is, wow, 24. That's really, really, really unusual. Let me go back and check my numbers, make sure I didn't mess something up. It was 2465. 2465 out of 3621. Let's see, 3621. Yeah, those are the right numbers. Wow. Okay, so and my sample portion is 68%, a whopping 68%. Here's why I'm so surprised, right? I'm really surprised, and I kind of was skeptical that my numbers were even accurate. How weird would a z-score of 24 be? Like, that's not even in the realm of possibility, right? Something is 24. That's like, I couldn't even expect that to be possible. But I think my numbers are all correct. I got P equals 0.48 and 0.48. Was 48%. Yep, that was it. All right, so here we go. So the idea is that we expected the sample proportion to be 48%, but what did I actually get? I got 68%. That's a really huge difference, and that's a really significant difference, and that's what that z-score tells you. So let me go ahead and put in the z-score, 24.18 it looks like. So let's do that. 24.18. It'll tell me if I'm right here. Sure am. That's the number. All right. And then the p-value. The p-value you have to get from StatCrunch, or I have to give you a screenshot with the p-value in it. You're not going to ever compute the p-value by hand because that's the area under the normal curve. So it's back to using a normal distribution like we used earlier in the course. I'm going to put, so here's what you want to do. When it says p-value is less than 0.0001, that means the p-value is so small, they can't even really report it. It's basically 0. So I'm going to go ahead and put in 0 in here for my p-value. Let me see if it takes that. Yes, it sure does. All right. So then based on that, do we reject the null hypothesis or not? So hopefully you're kind of remembering the patterns by now. If the p-value is small, we reject the null hypothesis. And that's the main thing to look for. If the test statistic is extreme, if that z-score is a really big number or a really small number away from 0, distance from 0 for the test statistic is what you're interested in. If it's really far from 0, then that's when you want to reject the null hypothesis. So yes, we are going to reject the null hypothesis, and that means we have evidence in support of the alternative. So reject the null hypothesis, the percentage is significantly different from 48%. Not even close. There we go. All right. Now it says enter a 95% confidence interval. So to do that in StatCrunch, you don't have to start over. Go back to your screen, your output there, and go to Options, Edit, and then just switch this to confidence interval. And they ask for a 95%. If they ask for something else, just change your percentage and click Compute. So here's my confidence interval. So my confidence interval for the same set of data, my lower limit is around 66.5%. My upper limit is around 69.5%. Notice, by the way, that it does not include 48%. 48%, remember, was what I was comparing it to for my hypothesis test. It should not include 48% at all because we said we think it's significantly different from 48%. So if 48% were included in my confidence interval, something's wrong with that. So let's go ahead and put that in. How did they want me to round it? They said, let's see, rounded to 4 decimal places. That means they want it as a decimal. So I'm going to do 0.6656, it looks like, for the first number, 0.6656. And then for the second number, let's do 0.6959. So 0.6959. Okay, so let's go ahead and check that. There it is. Does the 95% confidence interval coincide with what we said for the hypothesis test? So it says, yes, it certainly does. The result of the 95% confidence interval agrees with the result of the hypothesis test performed in Part A because the value of P naught, remember P naught was the percentage population proportion you used to develop your null hypothesis. P naught is outside of the 95% confidence interval because our interval goes from 66 to 69%. And there we go. All right, let me just scan through. Let me see if I can find one more. I think number 13 is very similar, so you're going to follow the same procedure, although your conclusions might be different. Let's take a look and see what else we can look at. Let's see. Let me just pick one of these ones at the end. These all look very similar. So I'm going to pick, let's try 17 here. It says, it was determined that the percentage of T's in the English language in the 1800s was 8%. Okay, so that's your population proportion of T's in the English language, 8%. A random sample of 500 letters from a current newspaper contained 53 T's. So that's your sample, right? Out of 500 letters, 53 of them were T's. Test the hypothesis that the proportion of T's has changed in modern times at a 5% significance level. So that's going to be your alpha, don't forget. All right, so let's see. What's this null in the alternative hypothesis? The null is that the proportion is still at 8%. The alternative is that the proportion of T's has changed. So once again, this is a two-tailed hypothesis test. So I'm going to pick choice B. Alternative is that P is not equal to 0.08. All right, let's go ahead and go to StatCrunch. So I'm going to go to question. I'm going to go to StatCrunch. Actually, if I had the window open, no, I closed the window. I was going to say if I had it open, I could just edit, but that's all right. So remember how to do this. We go to Stat, Proportion Stats, one sample with summary. So I had 53 T's as my successes out of 500 observations. And then my null hypothesis was that P was equal to 0.08. My alternative, again, it was not equal to. If it was one of the others, I'd just select a different directional and then click compute. And here's my summary. So my sample proportion is about 10%, 0.106. My z-score is 2.14. So think about what that z-score tells you. Would you consider that to be an unusual test statistic? And I hope you would say yes, because it's outside of 2 standard errors. Remember, we said anything outside of 2 standard errors is unusual. So that's what they wanted, was the test statistic. So if I rounded, it would be 2.14. So let's go back here and let's say 2.14 is my test statistic. And then the p-value, they have to give you that. So my p-value is 0.0321. So it says 3 decimals, so 0.032. Okay, and then choose the correct conclusion. So would you reject the null hypothesis based on a 5% significance level? So in other words, is your p-value less than the significance level? And the answer is yes. 3% is less than 5%. So yes, we will reject the null hypothesis, and that tells us we have evidence to support the alternative. The alternative was that p does not equal 0.08. So reject the null hypothesis. Let's see, the proportion of t's is not significantly different. No, that's not what we're saying. We're saying the proportion of t's is significantly different because we have evidence for the alternative. So my answer is choice D. All right, so hopefully this helps a little bit. I strongly encourage you to come to office hours on Friday and or Monday and Tuesday to go over this stuff again in more detail. If you have trouble with the homework, take advantage of that because this is really difficult stuff. So bring your laptop with you and we can look at whatever problems you want to look at from either 8.2 or 8.3.